What is the major differentiator when it comes down to Redpanda as a platform?
Can take all of decades of unmodified code, point it at Redpanda, and it just goes.
Data is the fuel of AI, and it seems you have a lot of it.
Every company has like a subset of approved models, but if I look in aggregate, they're all approved.
Fine-tuning pipelines with Redpanda.
What is the future? Because it looks different from where we are today.
You talked a lot about BYOC.
No, I don't want to have a hard dependency between your control plane and my data plane.
Do you have any predictions for next year?
Redpanda, the company.
Welcome back to another episode of AI Product Engineer Talks. And today we are delighted to have Alex Gallego from Redpanda, the CEO and founder of Redpanda. Hi, Alex. We're very happy to have you here.
Hey, Rob. Thank you for having me. Excited to be here and to share with the audience. It's going to be fun.
Although Redpanda is a very big name in some circles, not everyone knows about it. Maybe before we begin, can you give us just a quick overview of who you are and what's Redpanda?
Sure. So by way of introduction, my name is Alex. I was one of the early, or I guess original developer. I started the company in 2019 with the goal of building a simpler, basically data streaming platform. And so for those in the audience that have heard or are using Kafka, you should give me a call. Pretty easy to find out. The idea is like, can you build something that is really easy to use, that is sort of simple and performant and doesn't lose your data? Those were the original primitives. And so we got very lucky, perhaps in the data space. And so we powered the largest electric car companies, largest banks, largest CDNs in the world, largest sporting companies in the world. And so those tend to be our customers. For context, if you're in the audience, I think a lot of what I can share, it's biased towards perhaps the Fortune 5000, right? Like a much smaller group of use cases that tend to be like large and complicated. And so I think today is going to be an exciting chat. But yeah, happy to dig into anything on the infrastructure side or on the company side.
Coming from a messaging background, what is the major differentiator when it comes down to Redpanda as a platform for a developer?
Yeah, I guess, to get a little bit more technical, to the engineer, when I was writing the code, it felt like distributed system manual. So if anyone has operated a large Kafka cluster, you know that you have to have, zookeeper or, keep 500 quorum service manager, the storage nodes, the Kafka nodes, schema registry, and HTTP proxy, and then cruise control. And so when something goes wrong as an engineer, you're just like, well, I don't know, which, it feels like a Schrodinger cat experiment often, which is, the system is up, but my app is not making progress. And so it has been very difficult. And so for me, it was about building something that I wanted to use. And so it started with simplicity. And it was really rooted on two relative simple primitives, which is one, the computer I'm calling from is about 1,000 times faster than disks were a decade ago plus when the original system was built, and they're 10 extra. And so if you were to start from scratch, what would you do differently? And so the first thing is, it's super easy to use. And the thinking here is you can't eliminate essential complexity, you can only shift it around. And so if the job is to save data to disk, then the job is to save data to disk. You can't eliminate that, right? Like that's the job, that's what the software is going to do. But what you can eliminate is sort of the accidental complexity, the idea of managing and supporting that. And so the thinking is like, what is the simplest thing you can start with is you take one file, you put it on 1, 2, 3 computers, and you're done. Sort of the easiest thing. The second thing is that we made it really fast so that we could scale to some of the world's largest workloads that we power today.
And so if you look at the portfolio of companies that we've had, none of them have had to change a single line of code, which is sort of the magic that they feel when they interact with Redpanda. So you can take a 10-year-old code base, whether you're protecting whitehouse.gov or you're, powering, like, let's say, whatever, like a large vehicle fleet, or you're monitoring oil and gas pipelines, or you're doing like, you're processing payments for some of the world's largest companies. You can take all of, decades of unmodified code, point it at Redpanda, and it just goes. So it's fully Kafka API compatible. And that's really how we've gone to market. From an engineer perspective, it's been really fun to work on this distributed system challenges. correctness, all this stuff that like we want to spend time engineering on. But really from the end user perspective, is there like, it's sort of getting into an electric car with ludicrous speed mode. You kind of go and you hit the pedal and the thing just goes. That's sort of the sense that users get when they onboard with Redpanda.
Amazing. And we can all agree, I think, that data is the fuel of AI, and it seems you have a lot of it. So it was kind of a logical step to build a product around it. And maybe you can tell us something about that.
Yeah, I think all data companies will be AI companies. And you're seeing this with, Databricks and Snowflake, just to name a few. And it just sort of like the next logical steps, because what we found is people were struggling with making money with AI, to be honest. Like, okay, people can make a splash about it, but when you really ask, how many dollars is this new technology generating for you? And of course, there are lies, right? Like you have finance who are fairly sophisticated people and have been doing a lot of fraud detection or models for a long time. But if you look at largely at the rest of the market, most people really were sort of stuck in this design, like RFC document from the engineering team. And their roadmap from there to actually getting something into production was really wide for an internal team. And so if you think about it, it's not enough, like even if you're not building the model yourself, even if the idea is that you're taking a model and you're fine tuning and you're running it locally, it's like, okay, who's accessing this? At what time? And like that's just tied to my centralized identity management. Can I offboard an application? What is like, the ACO management system? Does it work with the rest of the provision in the step? Where does it run? Does it run inside my infrastructure? Do I have even the capacity to do this? And so all of the things that basically engineers get asked to productionize this system, that's what we felt we could really help some of the world's largest banks and customers. And so last year, in partnership with some of the world's largest banks, we asked them, hey, what are your biggest challenges? And so this was sort of the baseline. But the most important one, though, and perhaps the most controversial, is that they didn't want to share their data with OpenAI or Anthropic. And so when I probed into it, and I was like, well, tell me why. I'm new into this. I'm an infrastructure nerd. I'm not really an AI expert. Like, help me understand. And the thinking is like, your data is the alpha. Like that is the signal. You're gonna take this. Most companies are not gonna build their models. It's too computationally expensive. No one is gonna spend a few $100 million in training these things. But what you can do is you can take these open way models like Ollama 3.3, fine tune it for your use case, and get excellent performance. You drive better user experience. You often get an order of magnitude savings in cost efficiencies of deploying this. But more fundamental, even above that, was that you don't have to share your data with a provider. That was the sort of the longest ball. And so we call that idea sovereign AI. The thinking is like you can put a firewall rule that says no data leaves the network, and you still get to access this state-of-the-art technology to make your applications better. And so I think it's sort of been super compelling for us to have traction in the market in this idea of just helping them, our users get to market. And it's been part of the vision of the company for a long time. That I called it, helping the makers and doers build the future with that. And so, anyways, let me stop here before I can, because I could talk about this for hours.
I would be very interested in understanding how it works like in practice. Let's say like this example of the bank. I'm a large bank and I say, hey, I want to start doing some AI projects, but at the same time, I don't want to share my data with OpenAI because privacy reasons, compliance, and so on. And then I see sovereign AI on your website. What happens next? What's the next step? How do I go on about it?
It's a great question. So, there's one more thing that I need to mention here that is like a really important policy for large banks and organizations. And that's the idea of having an allow list and deny list of models. And so if you look at Qwen 2.5, is a great model, computationally speaking, and some regulated industries in the world will not allow those models produced by that nation state to get executed. Zero. They're like full stop for lots of historical reasons of, nation states trading secrets from companies. We're not going to allow Qwen 2.5, even if like computationally is a great model, right? It's just like And so policy enforcement was like another really big driving factor. But let me tell you what happens. And so you go on, and in May of last year, I acquired a company called, anyways, at the time it was called Ventus. We rebranded that as Redpanda Connect. And so the idea is that most people are where the world is today, and I actually want to share some thoughts towards the end of like where we are heading with this technology and kind of how what is the future, because it looks different from where we are today. And so you describe a pipeline. And so you say my input topic is going to be, let's say, financial, let's say take him 10K document summarization, right? You want to have, like, you want to be able to ask questions like, summarize the last 10K documents for all of the public companies that I'm following. You're a bank. And so the input topic could be the PDF. And so the first step is you transcribe it into text, and then you sort of extract information. The way to do it is you would set up a pipeline where the input documents would be submitted, or you can set up a crawler. And then you set up an access control list between the input model and the consumer code, which is this new product we bought called Redpanda Connect. That model, in it, you would say like, hey, I want to do whatever model thing you want to do. And you just give it one line that says Llama 3.3 is the model that I'm going to use. Maybe you're going to do vector embeddings or something like that. And what we do behind the scenes is we detect that this pipeline is what we call GPU accelerated in the cloud, inside your own network, which and we'll talk about bring your own cloud in a second. Inside your own network, we'll download the Hugging Face model into a new computer with GPUs, which is running an extension of Ollama, and then it'll load the model, whatever is from Hugging Face, into the GPU, and then through other code that we maintain, which is the Kafka-Go library, it'll connect to the input topic, and it'll connect basically to your centralized identity management provider, and it automatically enables like audit logs and whatever. And so from the point of view of the user, it's a YAML file, and you have an input topic and a model line, right? So like 10 lines of code, super cool. And so for some listeners in the audience, is ai.redpanda.com. There's a snippet. I'm not sure if you can bring it up as part of the podcast here. At the end, it's 7 lines, like 10 lines of YAML code, by the way. That's a real production pipeline. That's not like a, it's not a hello world demo that then you need to add other things. It's like, we took that, a real production pipeline for a bank, and we obviously changed the prompt and the input topic. And that's all you do. And so it's given developers this like phenomenal user experience of effectively a single line of code to change the model, to interact with other things, but all of the security and the sophistication of audit logs, allow lists, deny lists, enterprise security, centralized identity management, all of the things that you're going to get asked when you deploy to production is solved. And then we do it across the 3 clouds. And the reason people are using us or thinking about using us right now is that we invented it like about 3 years ago. I wrote, by the way, 3 years ago, this was also a really spicy take. This idea of BYOC, which is like, I'm now going to charge you resale value prices for Amazon infrastructure. Like, you pay with your own bills, because frankly, some of the companies that we work with have a better discount than we do. They spend like $250 million, or, actually some spend billions of dollars. Like, their commit is like multiple billions to clouds. It's wild, and it's phenomenal to work with these people. So they have better discounts than we do. And so we're like, why don't we like, figure out a way to run a fully managed cloud inside your network? And so the whole package, the idea that you get a fully managed cloud in your network with local model execution, is how people go about consuming this and deploying to production.
Pretty amazing. End to end for the developer, the best things to do, focus on value. That's what we like at the end of the day.
Yeah, and it's just such a long pole, honestly, to figure out all of those things. And it's like, I'm not sure that there is any value really for companies. I think it's relatively cost effective to use a service provider for this kind of thing. And it's like, okay, so you're gonna write the Terraform for 3 clouds, and by the way, integrated into your secret management of choice, and they all have different APIs. And so like that work is undifferentiated. For us, it makes sense because we're an infrastructure vendor, but for most people, it's such a waste of time and talent to spend 18 months or 12 months hacking around some Ansibles or Terraforms and integrate badge in your head against the table because all cloud API secret managements are slightly different, or the identity management is slightly different. So that's kind of like what prompted us to accelerate that.
And then you still need the data pipelines. You still need the data asset management. You still need everything which is already built in. So that's the next step. So now you can run servers, but you still can't fill them with life and make money with it at the end of the day. So that's the thing. So yeah, I used to work for a company who built their own infrastructure from the scratch. So every pain in there I can feel. So it's really enticing to have it like all wrapped up nicely. And you were mentioning something which is right now, I think, one of the hotter topics, I would say. At the beginning, it was all like playground with AI, and now we are talking about identity. We are talking about security. We are talking about governance a lot, especially in Europe. AI governance is a huge topic, and we are seeing some players in the market right now playing around with it. Do you already have like the answer, like that 1, 2, 3 for AI governance? That's the thing you need to track on the models, for example, how they are trained, how they are informed. What's the industry right now? How is it moving?
Yeah, great question. So our point of view here is like, I'm conflicted, right? Regulation is usually okay if done by people that understand it, but most of the regulation is often done by people who've never programmed in their lives, so they don't know. And so what is useful is, I think, this idea of safety in models. And so what we are seeing in practice is that the output of models are then fed into a safety models. And so that is like first line of defense. Because if you're applying to, let's say, for a line of credit, you don't want a racist response. Like, no, I'm not, I'm Latino. So it's like, Alex, you get denied your credit because you're Latino. I mean, I'm kind of exaggerating, but you get the point, right? Like, it's not your real company, and like for the right reasons. You don't want to make sure that the model says absurd things, and they're trained on internet data, which has dark corners, and so I think safety is real. What tends to happen is that this idea of tracing and manual auditing is where people are today. I think as we trust more models and as we start to stack them, so you start to work towards this idea of like an agentic world. That's like, anyways, we'll get to that, I'm sure, as part of this conversation, where you're like finishing end-to-end task for real, complete. But from just like, if you take one model, like sort of the lowest level, the idea of tracing, it's like, what is the input of data that generated this prompt? Because it's not enough to say like, I prevented this. Like, you need to understand what were the inputs that caused this particular response. And the way that I think about it is, you start with really, really cost-effective storage. And I say that because you want to store a long enough retention period on the like raw data set. And so let's say that you're using Amazon S3 as a bucket, right? And so Redpanda on the storage engine side, you can have unlimited data retention. And so the idea is like, as long as you produce to the Kafka API and you configure it in the cloud, you pay for one copy of the data that is on S3, and local disk is really there as a way to optimize the latency, because latency is important for this use cases. But largely, you're sort of offloading the data to a really, really cost-effective storage tier. And then you can add provenance headers on the execution. So you can say, okay, the result of this model has some header metadata that says this was the timestamp, the input topic, and the offset. And so when something goes wrong, you actually are giving the scientist or the researcher or whoever's going to look at the data some way of actually trying to figure out, what just happened. Like the reconstruction, the reverse often called tracing into like the origin data, has been so difficult. And I think the idea of a distributed log, not to get too technical too fast, where you have like, you have this immutability, you have like really strong principles already, which is, I think, why it makes sense for us to get into it. It's like, okay, the value as an architectural model that we give to developers is an immutable log that is infinitely scalable with S3. First value. The second value, now that you need to execute on these records, you don't need to store the log multiple times. You just need to store pointers to the original log so that you could reverse engineer what was the original input. So anyway, so in terms of tracing, of governance, etc., what we are seeing is one, model stacking, and so the output of the first model is passed through a safety layer. Um, period. Two, people are fine tuning this large models with data, and so what you're saying is like, hey, forget some of the configurations that you've seen in the past. Let me train you with a different corpus, or like, or fine tune this model with a different corpus. So like they tend to remember the last data set better than like sort of the earlier trainings. And then that those two things tend to deliver the most value. The next one is obviously tracing, being able to then like reliably all the way to the durable record that is stored on S3 transparently for the user, but you can effectively track the single input that generated this particular output. And then you pair that with high-level organizational governance models like allow list and then I list. And for some reason, this is something that blows my mind today. So we work with enough companies that every company has like a subset of approved models, but if I look in aggregate, they're all approved. It's it's whatever your legal department feels comfortable with approving. Like, maybe they really like feel comfortable with the French models and they want to use Mistral, or maybe they feel usually the meta models are pretty widely spread at this point, or maybe they have a relationship with Amazon or whatever. But like somehow the CIO is gonna get asked, what models are you allowed to execute? Like you can't just sort of let a wild I don't know, hunt or something like that to use any models. You have to like have some restrictions. So that's how I think about governance. Have we something completely? No, there's probably more sophistication, but so far that layered approach seems to be working okay for the companies that we tend to interact with.
And you were mentioning earlier about Bentos. I remember they had this very funny mascot. And so from the branding perspective, I a lot of like Redpanda because both very cool, funny mascots in different situations and so on. And I remember also with Bentos, the idea was that take a descriptor and then just like a YAML file, say what you want as your pipeline, and then this is all you need. And I see some of that, it seems now reflected in this implementation for Redpanda. You're mentioning now, Alex, the topic of so taking the data and then doing all this governance. And I'm wondering, so just as I can do this descriptor file for inference models that I can have like a Llama model, you were mentioning now Mistral, can I do the same for fine tuning and getting new models with my own data? That I say, hey, I am this bank, I have millions of customer records, I want to have a fine tuned model. And can I do all this within Redpanda?
Great question. So by the way, Ash is hilarious, and I've known Ash for many years. For those of us listening, he was the original author and creator of Bentos. And in fact, when I wrote the memo to the board um, to acquire the technology, part of the memo was for AI. We just like didn't tell the world about it because I wanted to prove it to ourselves. Like, can we actually go and create this? Remember that at the time, I mean, like AI has moving so fast. At the time, it was like, it was a way to just sort of crunch the data, filter it, sort of like very much in pipeline, like consume from Redis, publish to S3 kind of processor. And it was really helpful. And so as we started to kind of see people, and I was having those AI conversations behind her, like, man, people need vector databases, they need a BYOC version, they need they need governance, they need all of these things that we've added. They need actually access to all of the models, because even if we believe the future is like, effectively hundreds of thousands of local models in the future, with like perhaps some touch-ups of global models like OpenAI with function calling, and we'll get that in a second. Uh, you still need a way to kind of glue it all together in a way that, from a developer point of view, it's just not that interesting. It's not that interesting to develop some code to call an HTTP API. It's like boring. And for those of us that have to do it as a living and go back, and there's a commercial value for us, but like the value is in like helping people get that. And that feels really good. Anyways, so the reason why I think you're getting the feeling is like it's because it builds on top of the Bentos way of thinking, and Ash has sort of been instrumental as a thought partner for us to make what he used to call what is it called? I think stream processing made operationally mundane. As, because day two ops is really where people like we all get called. If any engineers listening to this, somehow it's always at 3 a.m. on a Sunday or on Christmas Eve that you get paged in to fix some production outage. And so like being operationally mundane and actually boring is a superpower of that technology, kind of a core of how to think about it. But anyways, that was very much the pillar of where we built this whole execution of AI models. And so it's just sort of the comment on Ash and the Bentos ecosystem. What was the second part of your question?
If so, we can also do full fine-tuning pipelines with Redpanda. Just as you were describing, we can do inference locally in our ecosystem. Can we also do the same thing for fine-tuning?
Yeah. So this the answer is with slightly more work, but not much more. And so there is a company called Poolside. They're like I'm a big fan. They are entering the I guess Gen AI space, and I guess the AI space in general, building a foundation model. So they're competing for general intelligence with OpenAI and Anthropic. They're on that race. Their go-to-market is around code completion. But there's a lot of overlap with how the way you go about training those models and building a general model. And so that's how they're going to make money. But they're in it. They're one of the few companies in the world that is trying to compete on a race with other really talented companies on producing a general intelligence model. So for them, the idea of incrementally and consuming streams of data. So they index the whole internet on top of Redpanda, right? And what they want when they want to launch an experiment of like, maybe 30% of this language or this model or however they break up the training of multiple models, they're sort of trying to run signals. What people that were training and fine-tuning things, they were just sort of stuck in this like preparing phase that would take multiple days. And so the alternative without Redpanda for those listening in is that you would consume the internet and you would upload this files. And so if you needed to prepare those files for training, because training is very expensive, it's like, hundreds of thousands of dollars kind of per hour. Like, it's not uncommon to spend $500,000 of training per hour at a large scale. So people wanted to like make sure that if you were going to spend that kind of money, it was with the data that you wanted. And so you would consume the internet again. And now you have your local copy, filter it into a smaller version because it's very expensive to go through that amount of data with the GPUs. And then do it. Anyways, that stage takes multiple days. And he just came to our virtual conference last week, Thursday. So perhaps we'll link it to the show notes. It's like a 3-minute conversation that I had with him on this particular topic. It's a great question. And he talks about, it's like, with Redpanda, you just sort of consume it, and then you just get to filter it dynamically. You don't have to do this like multi-stage filtering the pipeline. You could just go, right? So you sort of eliminate this like prepping of a data sets that are very time consuming. And so each time that you're testing a new combination, and so let's say that you want to fine tune a model with like either combination of data sources or combination of models, so that at the end you produce like a file, which is a configuration that gets loaded onto the model. You want to experiment. And so accelerating experimentation before you commit to it, it's where I think Redpanda really does help. And it all works through the whole, Redpanda as the storage engine, having infinite data retention on S3 with what was Bentos at the time, Redpanda Connect and Hands, to be able to, consume from streams at different ratios. And so if let's say you're a financial company, it's kind of going super into the weeds, but you ask, and you want to consume like transactions data or customer profile data, you can do a mix of the consumption of those topics at runtime. And so you just eliminate categories of complexity altogether.
Crazy. Because I think compared to like regular data, what is processed before, the challenges for processing data with regards to training models is the sheer size of a single message, isn't it? like from sizing perspective, like images or compared to text messages from applications.
Yeah. And often, I mean, you'll find engineers are really smart, and they'll find um, ways to saturate the devices. The real long pole often shifts between the GPU and network saturation tends to be the two like easiest bottlenecks to saturate. And once you like figure out the shape of your data, then engineers are pretty good at making sure that the long pole is GPU utilization. It's just so over the top expensive. But experimentation, as you're fine tuning, frankly, we're all trying to figure out how to do this. And the experimentation piece is so critical, because it's fine to pay a little more for like perhaps underutilizing some GPU clusters in the beginning when you're experimenting, like, how am I going to go about fine tuning this thing? Like, what are the data sources? What are the combination of inputs that I'm going to use to fine tune this particular model? Like, I think that is pretty critical, because we're all trying to develop an intuition for it. And but anyways, something is better than nothing. And so if you do something, like you're better than most people. But being able to experiment quickly and then discard experiments, it just like, think of it like a superpower. At the end of the day, the GPUs are gonna do the majority of the work. But experimentation, I think, is a superpower that people can get, frankly, relatively inexpensive and quickly, all things considered. Because in a BYOC context, we're not gonna charge you really a significant sort of value increase for what you're already paying. And so it's sort of like the best of both worlds. You run it in your own infrastructure, you have it in your own VPC, and obviously take it with a grain of salt, because I wrote the part of or work with the engineering team to design BYOC, but it executes locally, so you're not sharing your data, and you're going to be able to experiment quickly, and you're going to produce ultimately a better user experience.
And I would like if we can spend some time on the technical implementation of sovereign AI. I was looking at the website and then I see that is somehow connected, or like a wrapper around Ollama, which is this popular open source project for running local LLMs, which I find it fascinating because when someone thinks about Ollama, one thinks, oh, I have my laptop and I want to run a Llama 3 locally on my laptop. So then I just download Ollama and I use that, right? But then here you're doing that at like an enterprise scale to power, for example, bank applications, pipelines, and so on. And what I know is that Redpanda is also implementing C++. So I'm very curious on how this is messaging the connection between the Redpanda implementation and then having this interface with Ollama and all the AI stack that you have developed around.
Yeah. So we have, you can think of Redpanda, the company, as like three major products. We have a UI. By the way, that was an acquisition that we did a few years ago. Martin and Maurice were phenomenal engineers on the best Kafka UI in the world that existed at the time. I was like, I need that. Because, we're just a bunch of C++ storage nerds, mostly, and we didn't have a lot of strength in developing like interactivity. And so if you have the funds, you go and sort of like artificially acquire the skills that you need to deliver a good user experience. So that's the first one. And I'll tell you how it all integrates into Ollama in a second. And so the C++ binary has always been the core of the storage engine. And then with the acquisition of Ventus, that was sort of the third core product pillar. And then they get deployed in a multitude of ways, so we don't have to cover that. But largely, so the processing, which is Ollama in particular, is embedded as an extension of Bentos. What was Bentos, what is now Redpanda Connect. And that is all Go. And so that is a separate binary with a separate set of pools of servers that is scaled independently from your storage needs. And the reason is that GPU and CPU utilizations are different scaling vector mechanics than the storage, which often tend to be either IO or CPU bound, not network bound. And on the compute side, you can shift pretty dynamically between network boundness and CPU or GPU boundness, really like at arbitrary points. And so you need a lot more dynamism than you need on the storage side. And the UI connects with the processing layer in that that's where you enter the YAML text input. And so the YAML text input is where you enter in the UI that gets posted to a Redpanda Connect streaming service as a HTTP post, and then it runs it. And that's how roughly the infrastructure kind of works underneath the covers. Although that's fairly, and by the way, all this code is on GitHub in case people wanted to check it out. But the main thing that where we added was networking, enterprise networking. And there's an inordinate amount of complexity. I think we spent 2 years, a relatively large team of people effectively focused on making sure that networking works with enterprise customers. The reason is like, when you start working with large companies, they're not going to give you a large IP space. They're like, how many computers do you need? 5, and they'll give you an IP space of like 7 computers, and you're like, this doesn't work with Kubernetes well. You know what I mean? And so you have to start to map the enterprise networking rules into like your product. And that's, I think, where part of the magic feels to the end user. You're like, man, I'm at this company that is really challenging to get and deploy a bunch of things. And here comes Redpanda. They allow me to use the state-of-the-art technology, whether it's the Kafka API through Redpanda or consuming these models, in a way that I have to struggle or battle with my IT systems, with my networking space system. And so I would say like that's really where like a core of the IP of the service is, making sure that you're using TLS only. So you're not using, plain things, because I know someone's going to leak some data and we're going to get blamed for it. Even though it's like inside your network, nobody can access. But anyways, right. So making sure that your TLS certificates are using like the latest encryption standards, making sure that we don't allow unsecure ciphers, making sure that your DNS routes are updated quickly, making sure that you only have one broadcast of the IP address space, making sure that we can either absorb it or you can pair it with the private service connect or inside your own VPC. Honestly, networking is just about the gnarliest things, and I'm thankful to my cloud engineering team. That's something that I'm like not as intimately familiar as my team. It's just super talented. I'm more like the core on the replication side. Um, that's probably where like a lot of the enterprise value is delivered. Is like, how do we remove obstacles that are a lot of time are self-imposed from large organizations? And I think it reduces to networking. Like, it's just so hard to get approval for some of these teams to get security and the IT team to give them like enough IP space and to do this thing securely. So anyways, at the lowest level, you have these 3 products: the UI, the Redpanda Connect, formerly called Bentos, and the storage, sort of working seamlessly. And the reason it can integrate with Ollama is because the processing side, Redpanda Connect, was a Go binary from the get-go. So Ash had seen the future. And I think for those of us that have written integration, Go feels like the new Perl of the 2020s. And so for those of us that had the displeasure of writing Perl Golf, it's like there's a little library for everything. So it's like a great little language, or not little, this is a great language to like connect to just about everything. And so that's why we chose it as the base for processing.
Absolutely agree. The closer you want to go to hardware and you need to have like the speed, Go is a great choice. From a software development perspective, when you look at supply chain management, it's a nightmare. Most of the applications, because they pull in GitHub like hell. But if you're not going down that road, everything is cool.
Yeah, it's like JavaScript too. I think on the core we have something like nothing, I don't know, like 17 dependencies, and some of those are like OpenSSL. That's like 3 compression libraries. And so we have Boost libraries for some like shared pointer mechanics and being able to jump stack frames on our core routines, implementations, and things like that. And then, and that's counting the Boost libraries independently. And like, it kind of starts to dwindle on like JavaScript projects or Go projects. It's an inordinate amount of dependencies. But also, I think that's true for integration plays. And so I don't discount that the reason we're seeing some success with Connect is that people don't want to like keep up to date the security policies with integration systems. Because if you think about it, if the job, we talk about essential complexity early on, if the job of the thing is to do integration, then like by there's just nothing that you could do than like basically have sneak reports or whatever security vulnerability management every day. Just like, like we patch the code. I think we release every week. sometimes even multiple times per week because we want to stay ahead of things. Um, but because the job is the data integration space.
Yeah. So then I guess also like things like SOC 2, all these certificates which are running around are covered right now.
Yeah. When we're like, HIPAA compliant, SOC 2, Type 2 compliant, et cetera. And so I think that's a big difference. To talk about sovereignty, Raw 2, and then Jens, you ask, is the sovereignty is different than privacy. And the way for listeners to have a mental map of what it means is privacy is I'm going to take Alex, I'm going to scramble the social security number and encrypt the data at rest. Frankly, security came up with a checklist that I don't really know why I have to do this, but I have to ask my vendors, do you support? It's kind of like where privacy is. It's more than that. I'm being a bit facetious. Sovereignty is more it's more difficult to achieve, and it says you own, in my opinion, the hard drive life cycle where the data actually lives. You control that. Like at any point, you can just say like, I'm gonna shred those hard drives. And there's like nothing that you could do. And so that's really the main difference. It's sort of the ownership. Who owns the data? Is it you or is it a vendor? That's basically the main difference and why we believe so strongly in this idea of BYOC. It's just the future is going to be BYOC, and I think people are going to get left behind otherwise.
And Alex, so you have this interaction with Ollama. I'm curious, why Ollama? Was there a decision making? Because of course in the space there are other inference engines. So there is a text generation interface from Hugging Face, VLLM, or you could also say, hey, let us do our own Redpanda inference engine, like a homegrown version. Why Ollama?
We started with our own homegrown version. So we took Llama CPP, but we're a C++ project, right? And so it's like a relatively dependency-free project. If we have expertise, is in building a scalable C systems. It's kind of like a core of the skills of the engineering team. Um, but I think the speed at which Ollama, like, it's fascinating. They do such a good job at adopting new models. It's insane. It's like 2 hours. Like, Mistral will do the cool trick where they post a tweet. And then like 36 minutes later, Ollama's like, oh, we've adopted this new PR. It's just sort of mind blowing. That whole community is just so impressive. So that's one. Two, VLLM is good. And I think even OpenAI uses it internally. I know Snowflake is using that for their model inference server too. It's pretty good in general. But largely, I think where people were is like the developer experience was where people were being stuck on. And the way that we reasoned about it is that we built integrations with the OpenAI HTTP API. And what's cool is VLLM supports that as the main API, right? And so it doesn't stop us from swapping the implementation to a VLLM HTTP endpoint because we already have the OpenAI integration inside of Redpanda Connect. It was sort of like the fastest way to deliver the largest amount of value to people. Is kind of how we saw it. And then yeah, I think it's fine for all of the streaming use cases. The performance is good enough for the use cases that we're seeing. Um, it hasn't been a bottleneck. I think the minute that it does that, it makes sense to think through like, hey, do we write our own thing or do we use the VLM? I know there's like a bunch of other new frameworks that are trying to improve on latency and performance. I'm not sure the world is being bottlenecked with that. I think like the real shift in the market has to be we all come to consensus and shake hands. And it's like, yes, we buy into the future, that the future is about hundreds of thousands of little models running in your infrastructure. And I think at that space, you would want almost a different serving tier entirely that is just dedicated to whether VLLM is the output or not, but effectively the OpenAI HTTP API became the de facto standard. And you can have like hot model swapping. There are entire hardware companies, by the way, dedicated to this. So the space is so rich that you can, there's a company, I think Sambanoa Systems, where they can swap the model in memory in like 100 milliseconds or maybe less. And so, and they have a pool of hot models that are running in memory. And so it's just the spectrum of these things will exist in practice. And Ollama was a really good trade-off to solve what I felt was the longest ball here, which was the developer experience.
Absolutely. And that's at the end of the day, what's the most important thing, in my opinion, as being a developer. Um, yeah. Again? Not, yeah, yes, not biased, not biased, not biased, not at all. You talked a lot about BYOC. Maybe you could, just like for the listeners who are not too familiar with the acronym, tell again what are the different ways how you could run the thing.
Yeah. So in general, cloud services are what we call sole tenancy or multi-tenancy. And so in the multi-tenant world, you have things like serverless. We have a serverless version of it. And the idea is that you put some sort of proxying layer in front of the underlying storage systems so that on the same hardware, you can host multiple tenants. And you do that through virtualization and encryption, right? And so you take a single customer traffic, you virtualize it and you encrypt it on the fly, and then you have an oracle that will translate what a customer sees from what the proxy tenancy is. So from a user point of view, it's all transparent, but on the back end, it's all like encrypted and virtualized, and so you're using tenants there. On the sole tenancy side, that it tends to be what was like dedicated, and so for regulatory reasons, you want like on these VMs, the only workload that I want it to be my workload, and your bank X or large company X. And in the BYOC model, so over the last 5 years, these cloud vendors, Amazon, Google, and Azure, sort of started to provide enough richness on their APIs to give users a fully managed cloud that was sole tenant to them inside their network. That was sort of the main thing. And so we call that concept BYOC. And I think for me, it has really three pillars. One is this idea, we call that edge deployment data plane. It's this idea that every data plane is fully atomic. And so in other words, that you don't have a dependency to the control plane being up for your applications to run. And I think this is where people really need to double click. I think a lot of new technology vendors that claim to have BYOC, they don't have the most important property, which is data plane atomicity. It's like, no, I don't want to have a hard dependency between your control plane and my data plane. If my data plane, like if you crash for whatever reason, that's your problem. Like, just because applications this is just how developers run. Like the reason why you run a little 3-node Kafka service inside your infrastructure is because you can control it. And you don't want to have a dependency with the accounting team or the other engineering team or whatever. You're like, I need to give SLAs and I'm going to get paid and I don't trust. And so I want this thing, I want to control. It's sort of having that same, vibe to these things. And the only way to do it is if you have true atomicity of the data plane. So that's sort of the first principle. 2 is that it has to be fully managed. And 3 is that it runs inside your network. And so those 3 pillars is what I called bring your own cloud. And so in Amazon, it looks like a project ID. In Google, it could look different. In every cloud, there's like, low-level technicalities that are different, but the end result is the same. The user experiences a fully managed sole tenancy SaaS inside the network boundary that they control.
Thank you for a great explanation.
Alex, as a last question, we're coming almost to the new year, so we're about to wrap up this year. Do you have any predictions for next year in AI and also any hot takes?
I'm Clement, so I have a bunch of hot takes all the time. Just ask me on Tuesdays. So just like, even just trying to filter through that. So the main one is that where we are, it's pretty early, really. Like where we're seeing customers wanting to go with AI in particular is that they want to give this things like higher level tasks. And so I think Satya probably framed it the best. And so CEO of Microsoft, he said it's like most applications are like a little sprinkled business logic on CRUD operations on a database. When you really dig down, I think it's technically speaking, there were a bunch of papers written last decade. They called those things control plane databases. Anyways, I think he's right. And I think what we're going to see is this intelligence tier being replaced by just AI agents, and agents being not just one model, but being sort of like the stacking and accumulation of of a bunch of models that at the end to end, have one like business impact. And so like find calendar, with wrap. And it's like, it's Q4, so it's hard to find time. I'm not calling us out, but it took a long time to find time because, I was busy in this Q4 closing of the year. And so, but like that kind of high level task that you would assign to a human, or it's just a small business logic. So that's where the world is heading. And at the rate at which things is changing, I wouldn't be surprised if there are going to be a couple of winners next year that set themselves apart for thinking about this end-to-end agentic workflows. And here's the long fall, perhaps the spicy take that is not enough to have a good developer experience on the model side. You actually have to bring in the portfolio of connectivity to internal and external systems. And that's going to be hard. And so it's going to be challenging, I think, for early companies to compete because like the bar to compete is with like Microsoft or with people that have BYOC, that have figured out networking, my point of view anyways. And so it's going to be fun, but that's where I think the world is going to be. It's realistic that it happens next year.
Well, it has been a fantastic discussion, Alex. So we have really covered a lot of ground, and of course, we could spend here hours. But if anyone wants to reach out, contact you, get started with Sovereign AI, how can they do it?
Easiest thing is go to ai.redpanda.com. There's a form there. You can even say, hey, I want to speak with Alex if you want to have a one-on-one chat. I'm always happy to chat with people. On Blue Sky and X, my handle is EmaxAir now. Really super, super easy to get access to. I'm relatively active there. And then we have a Slack. And I do a bunch of Slack support. So often I'm on like cab rides, I'm on like an Uber, or I'm on an airport flying to London or something like that. And like I have weird times of downtime and I'm traveling a lot. And so I'll go into the community Slack and answer questions. So those are the three simplest way to get in touch with us. Thank you for having me.
Well, thank you so much for being here today, Alex. It's been fantastic.